Thank you, Jennifer. So yeah, I graduated. Somebody just asked me when I was at MIT. I graduated in 1965, so that was a long, long time ago. And I've had many different careers, and the last one was in building science, where I was a member of ASHRAE voting committee on ventilation, on duct leakage, et cetera, et cetera, et cetera. My company worked across the country, and my former company still does, and around the world. We did work in Canada, we did work in Saudi Arabia on energy efficiency, primarily with air conditioning and heat pumps. Saudi Arabia has a lot of air conditioners. Kind of hot there. They have really low efficiency air conditioners, and so we were paid by the kingdom to tell them what to do to fix their problem, of which they paid some attention. I find that, by the way, and you'll see me getting a little defensive in this presentation, because I love to tell people, well, like lots of people, I like to tell people what to do, and then when they don't do it, it's kind of annoying. You know? So anyway,
agents never have that problem at all.
So anyway, so I can get started so that folks aren't hanging around just watching us have fun here. So for any of you who aren't here, you can put it on your cell phone. Come on down. There's some lovely food here. There's wine. There's cheese. I mean, oh my God! Like I may come. Is it happening once a month?
Once a month, the third Thursday of every month.
I may come every month from now on.
And this is our first time back in person.
Oh wow! Okay. So yeah. Okay. So all right. So I'm going to talk about heat pumps and mini splits, but and basically it's set up to answer questions primarily. And anything that has to do with building science. And for those of you who don't know, the picture in the lower right-hand corner is of a baby whale down in the birthing lagoon in San Ignacio Lagoon. This is it's a good friend of mine. I can't tell you whether it's a male or female. They have to roll over for you to tell, and they don't often do that.
Not offered.
But anyway, so I petted this whale. It's a very nice whale, very good friend of mine. Okay, so come on, baby. Why don't you want to move? Okay.
Can you just click it in the tray there? Just right down at the bottom here. Can you?
There we go. Boom. Got it. Okay. So the first thing to do is I'm not going to talk about heat pumps or air conditioners at all. I'm going to talk about what's more important is that you reduce the load. Okay. Because reducing the load is the best way to save energy is to not use it at all. Okay. And so if we reduce the load on the house, then we can, and we do that by insulation, air sealing the structure, in summer, opening the windows at night, closing the shades during the day, installing a whole house fan that vents directly to outside. One of the things that we did, and so we do a lot of experiments. We have five. We have 5 test homes in Stockton, California that we've been monitoring for almost 10 years now. Maybe it's even been 10 years. And so we make different changes to it. And one of the things that was the most cost effective that we did in those houses was to put in a whole house fan and vent it directly outside. So take care of the whole system design and installation. It's way more important than the rating of the box. So everybody says, oh, I got something that has an SER of 29. And somebody else says, oh man, I'm sorry. Mine was only 14. And it's like, the box is only mildly important here. It's what you hook it into and what it's trying to do. So pay attention to the caveats that I'm saying. First of all, don't make it too big. Any of these heat pumps and air conditioners, if you put in the size that your standard contractor is going to want to put in, it's going to be too big. Okay. And when it's too big, it's less efficient. Okay. Because they don't put in an oversized duct system to go along with it. By the way, they put in an undersized duct system with an oversized air conditioner, which causes you all kinds of problems. So what you really want is a small air conditioner or heat pump, okay, with short ducts. So you don't want to lose a lot of your cooling and heating into the attic because you've got 100,000 miles of ducts in the attic, okay, or in the crawl space, either one. And pull permits and get energy rating inspections. That's something we have in California. It's not implemented as well as I would like to see, but it's a step in the right direction. Okay, so here's a good summary of how to do it right. If you go to this tiny URL, you can download this, which is a guide to actually how to get your house to be better. So that the air conditioner then or heat pump makes sense. Let me go previous for a second. So an example is that I have been to some people's houses who asked me to come in and talk about and look at what they should do. And what did I find? I find if I go up into the attic and I look around, then a couple things. Like I take a look and I say, oh, this. If I look at fiberglass and it's not pink and it's not kind of yellow, but it's black. Guess what? It's because air has moved through that insulation. So we have air leaks into the attic. Big, huge heat loss is you can put 100,000 pounds of insulation in your attic, but unless you have it air sealed, the air is just going to go around and it's not going to make any difference at all. Okay. So the R value of the insulation in the attic is only important once you got the ceiling plane air seal. So very important thing to do. All right. So I have lots of these as we go through. So any questions? And if there are any online questions, is there any way you can get online questions?
Yeah, I get them. Heidi's moderating, she can read them out loud.
Okay. So does anybody have any questions on what I've said so far?
Right on the website.
Oh, you know what? It'll be on the recording and I can shoot it out at the end.
Oh, okay.
Yeah.
Okay. You can write down if you want.
Yeah, question.
Yes,
So
sir.
one air seals by somehow treating the ceiling before the insulation goes in, or
Yes.
after?
Absolutely. And so people say, oh my God, I'm already insulated. How do I air seal? Well, in the old days, because I've been at this for like 35, 40 years, we used to try to move the insulation back, find all the leaks, seal them up, and then put the insulation back. That never worked very well. I mean, it worked better than nothing. But now what they do is they just go in, they take out all the insulation you got, okay, and air seal it. And then they re-insulate. Okay. So it kind of seems kind of stupid, but it actually works. So it's worthwhile. Did you get that? So
Yes,
What do they
thank you.
use to air seal?
when they use the air seal, well, it depends on the size of the leak, size of the crack. So in some cases, it's just foam. It's urethane. I don't know if it's urethane or not. It's foam, closed cell foam. Okay, and then bigger ones, they'll, it might be a board that goes across it, might be metal, depending upon, what you're closing off. But you go around the whole attic, and the biggest leakage in houses in California, because we measured hundreds of them, okay, is into the attic. That's the biggest leakage space in California, because most of the houses in California are slab on grade. They don't leak low. The walls, they're getting better. The windows, they're getting better. The ceiling is not so good, right? So that's where most of our air leaks are in California. Did I answer your question? Okay. Anything online? No? Okay. So this is how air conditioners work. So basically, air conditioners remove heat and moisture from the inside. So there's an indoor coil, which is cold. Air is pulled across it. Okay. When the air is cooled, okay, because it's a cold coil, you cool the air, and it also condenses moisture on the coil. Okay. And all of that is discharged outside. Okay.
Hopefully,
What's that?
hopefully.
Well, yeah.
The biggest thing we see in home inspections is that the discharge is not actually making it all the way outside of the house.
Yeah. So some people just put a pipe down into the crawl space, not so much in California because a lot of slab on grade. We've actually found stuff around the country. There was one where the condensate line went straight into the return plenum in the crawl space. So it just recirculated the water back around. So yeah, so I mean, the idea is that the moisture goes outside. Now, California, that's another issue, by the way, and we'll look at that in a second. Okay, what is that? Well, California is dry and needs very little dehumidification. And air conditioners, okay, are not built for California, and they're not built for Florida, where they have lots of moisture. They're built for like kind of around in here, sort of in Kansas. You know that the standard air conditioner is good for Kansas. Okay, it takes out the right amount of moisture for Kansas. It does the right amount of cooling for Kansas, but the wrong amount of dehumidification for Florida, and the wrong amount of sensible cooling, reducing the temperature. Okay, for California. Okay, so what do we do about that? Well, we've tried to get them to re-rate the way that air conditioners are rated for hot, dry climates and hot, wet climates like Florida. That's only been about 30 years of work, and we still haven't succeeded. So what can we do instead? Well, in California or any of these hot, dry climates, we want in cooling, we want the airflow to be 500 to 600 cubic feet per minute. That, just to give you an idea, the average airflow of an air conditioner in California is about 325 CFM per ton. And what you want is 500 to 600. And you want short ducts, because again, once you put that air into that duct, you don't want to lose all that heat or all that cooling into the attic or the crawl space. So plus, it's easier to move 600 CFM per ton through a short duct than it is through a long one that snakes around all over the place. Okay, and it's got kinks in it and everything else, which is just standard methodology. So you really want short ducts, short, straight, beautiful, wonderful ducts.
I have a question.
Yes, ma'am.
So if it's at only 325 and you want it to be twice that almost,
Mhm.
What, do you need a stronger unit to push more air, or what is the solution to that? Like,
Well-
what are you asking them to do?
Well, what we're asking them to do is to think in advance.
That's.
Okay, well, and that's hard.
That is the.
That's
challenge
hard,
right
you
there.
know. It's like a really hard thing to do. But okay, number one, how can I increase the CFM per ton? Well, number one I can do is, oh, here it is. Why does it say minute? Oh, it's over here. It's ton. I can reduce the tonnage, because air conditioners in California and all over the country, for that matter, are too bigger than they need to be for the houses. Okay, so to reduce the tonnage, then I get more CFM per ton. That's number one. Number two, instead of these long snaky ducts that you have to like force through with a fan that rate uses a kilowatt when it's running, okay, put a short duct, okay, and no kinks in it. If you have to do bends, you do them with metal, and so metal. We used to make ducts with metal, by the way, the old days. But anyway, and put a nice bend in it, and go to but keep it short, and then you get lots and lots of flow. Okay, and you don't have a lot of use a lot of kilowatt hours or watts. Okay, with the fan. Okay, and you get what you want, which is a lot of sensible cooling, a whole lot of reducing the temperature, and very little dehumidification. Okay. Thank you for that question. All right, now all I have to do is teach all your contractors this. Okay, Any other questions with my little guy here? All right. Nothing online, right?
Nope.
Okie dokie. All right. So this, as I said, and no offense intended to anyone here, or anyone who isn't here. I understand that trying to take my recommendations and implement them run into a number of problems. And that is the standard thing a contractor does is not what I'm talking about. And so when you go, you say, okay, well, I have this guy that I roll with, he's kind of cool, and I think he knows a lot of stuff. And he says, you ought to do this. And they say, nah, we don't do it that way. No, you can't do it that way. No, can't do it. Okay, so this is an example of a friend of mine who put in a new unit in their house. And then the unit failed, the fan motor failed, the motherboard failed. It happened repeatedly. And this was, by the way, after I told them what should happen in the first place, which didn't happen because the contractor didn't want to do that. They didn't want to replace the existing ducts. What they want to do is use the existing ducts instead and put in a new air conditioner, and which they did. They put in an oversized air conditioner with existing ducts that were long and snaky and et cetera, et cetera. And so they didn't have enough airflow. So the inside coil, this is on the outside of the unit, but the coil inside is just a solid block of ice. Okay, and so the fan burns out, the motherboard burns out, et cetera, et cetera. It's quite, it can be quite expensive, especially if they say, well, that's not under warranty. Well, what do you mean? You're the one who screwed it up, But anyway, ignoring recommendations, it has its pitfalls. Now I'm going to talk about heat pumps. Remember, I talked about air conditioners. What they do is they remove heat from inside and discharge it outside. Well, a heat pump is it just has a little valve here that switches direction. Okay, so what it does then is it removes heat from the outside and discharges it to the inside. So if you assume that an air conditioner isn't magic, then a heat pump isn't either. But then, of course, if you think an air conditioner is magic, then of course they're both magic. All right. So air conditioning and heat pump ratings. So we have a big problem with respect to ratings. Okay, and we don't have to go into the details about this. I could talk to Tom about this later because he's like one of them engineer type guys, But the important thing is the contractor is going to want to talk to you, or the manufacturer want to talk to you about the cooling SEER, okay, which is called the seasonal energy efficiency ratio, which, by the way, is not what it is at all, but that's what it's called. Okay, so I mean, it's a good idea. Having that would be great, okay? But the way that they create that number is different between different kinds of air conditioning, between a single speed air conditioner, a 2-speed air conditioner, a variable speed air conditioner. And so the numbers don't relate to each other. So you can't make a decision because, oh, hey, this unit says it's going to be a SEER 59, and this one says it's only a 23. They're not comparable. It doesn't, it's like, so what do you want to look for? You want to look for a thing called cooling EER, okay, which is a very, very stable test. It gives you a good idea for what the efficiency of the unit is, okay? And you have the same problem in heating. They want to talk about HSPF. Again, what they come up with a number based on a whole bunch of manipulations and a bunch of assumptions, et cetera, et cetera. What you should look for is COP, okay, which is a very straightforward test. At a given set of conditions, you measure how much heat is put out and how much energy it takes to do it. Boom, easy peasy, okay?
So John, the seasonal ones don't work because they take in too many variables, just like the seasons.
Yes,
And so that's how I would
And-
remember.
and-
is
and the
seasonal
temperatures.
one is no, the other one is yes.
yeah, right.
Okay.
Well, and it's because they try to get to what they're saying. But given that their testing doesn't really give it, then they have to make a bunch of assumptions from the tests that they did to what it really means. And the tests are different between different kinds of units. Okay. So that was a good question. The cat likes it. Any,
No, but they're all hooked into the chat, so I know. but I
Okay.
don't know.
all right. Okay, so let's talk about conventional heat pumps. So conventional heat pump has an outdoor unit, has a single indoor thing like the pictures that I showed you before. Like this, okay? And so that's a conventional unit. Single outdoor unit, indoor unit with a fan, ducts that deliver the stuff all over the house. Probably ducts that are too long, probably ducts that are too restrictive, probably ducts that run through the attic and lose a lot of their heating or cooling in the attic, et cetera, et cetera. But that's a conventional one, okay? And so you can put it in, take care of the whole house, okay? Now, if you're gonna put one in, I would recommend a 2-speed unit because the 2-speed units are a little bit more expensive. Okay, and these are just to give you a rough idea of prices, 12 times $600. For those of you who can multiply that, that'll give you an idea. Okay, EER on a conventional heat pump, a 2-speed conventional heat pump is like EER of 25 and a COP of 4. Okay, now that's pretty darn good. I mean, it's not the greatest, but it's really good. And if you put it into a house and you actually take care of the ducts as well, then you can get a really nice performing system. Okay, now there's a little problem associated with most conventional heat pumps, and that is that they add in a backup because they think that they're probably putting in a heat pump that's too small to meet the demand when it's cold outside, which most of them are so freaking oversized that it's totally ludicrous thought in the first place. But they put in this thing that you might, this might look like something that you find in your kitchen. Anybody know what that might look like in your kitchen?
The toaster.
Toaster. Yeah, it looks exactly like a toaster because it is. I mean, actually, that's a backup. That's electric resistant backup heat that's often put into a heat pump. Okay, so first of all, don't put one in. If you put in a properly sized heat pump, you're not going to need backup heat anyway. Number two, if you end up for some reason because the contractor and you can't find a contractor who won't do it, then lock it out whenever the temperature is above 35 degrees. I mean, basically lock it out forever, but 35 degrees and whatever.
We have 3 days a year.
Yeah, right. Okay.
It sounds like these things are designed for Kansas once again,
Yeah, they're good Kansas. Yeah.
where you're gonna get huge temperature extremes.
Right. Yep. Okay, and the COP, by the way, the COP of a good 2-speed heat pump is 4, and the COP of this electric resistance backup is 1. So it uses 4 times as much energy to give you the same amount of heat. Okay. All right. Now, if you really have a lot of bucks and you want to be totally cool, then you can get a geothermal system. Okay, very expensive. Every time we monitored a geothermal, so basically what a geothermal system does is instead of taking heat, thinking of it in the heating mode, instead of taking heat from the outside air, which gets cold, you take it from the ground, which doesn't get as cold. Actually, it stays moderately warm. And so theoretically and actually, then that can be real efficient. Okay. And, you know, they can be real efficient, but they're expensive. And we found out that doing a really good job with a more conventional system will cost you, you know, less than half as much, and actually give you the same energy efficiency. So we've actually had 2 houses side by side, one with a geothermal pump, one with a really well-designed conventional. I'm going to say that in quotes because by conventional, I don't mean 350 CFM per ton and long stupid ducts and oversized and all that stuff, but well-sized, short ducts, high airflow that ended up at the house with the conventional system, okay, use less energy than the geothermal house.
And that one had the fan.
What's that?
That one had the fan.
You're talking about the whole house
The
fan?
The whole house fan.
No, those are, that's a different test.
Okay.
Yeah. So this is a, you know, like if you just take this house, you put into it short ducts, properly sized air conditioner, the right amount of airflow, boom. Okay, we can use less energy than the geothermal did. Okay. All right. So very costly, highly efficient, low annual costs. Okay, now we can talk about things that people are like, oh my God, this is like so cool because over in Japan and China, they've been doing this forever. And so they're very smart and they're very smarter than us. And so therefore they must be cool. Okay, ductless mini splits. Okay, so this is, it has an outdoor unit, okay, and then it has an indoor unit. Now this is a ductless one, so it goes up on the wall in one room, okay. And but if you actually want to heat your house, okay, then you need one of those in every room that you really want to have heated. Okay. Now people say, oh, you know, I just put one in this room, and then excuse me, I'll run a fan into the other room.
No,
Doesn't work.
no one does that.
No, we've tested it. You know, people insist we have to test it, so we tested it. No, it doesn't work. It number one, it doesn't heat the other room, and number two, it costs you extra for the electricity to run that fan. So it kind of fails in both categories. Okay, then you have ducted mini splits, and a ducted mini split is a really nice substitution for an old-fashioned conventional one with the long ducts that go everywhere, and they can be properly sized. So in my house, we're putting in a 3/4 of a ton heat pump. Okay. Whereas I talked to somebody on the phone the other day, another friend of mine, who said, yeah, we're thinking about getting a heat pump. And so the contractor says, okay, for upstairs, we need 5 tons and downstairs we need 3. And I'm going, nah. So anyway, you can get them really small. They can serve multiple rooms, you know, that are close together because you want to run short ducts. And they're actually very beautiful. And we've done a lot of testing with them. You can screw them up, just like you can a conventional one. Okay, but they're really a good piece of equipment. Again, don't, when somebody says, oh yeah, this ducted mini split has a SER of 43, you just ignore that. Okay, it's like when somebody else says, oh yeah, this one over here has a SER of 32. There's no way comparing those two units, forget it. I mean, what we found is that the ratings, when we actually put them in houses and see how they do in the same house, year after year after year, we find out that the rating is irrelevant to what it actually does. Some of them with high kind of end up medium, and some of them are medium, kind of a little bit above medium, you know, et cetera, et cetera. So yeah, don't get all excited about SER. Take a look at EER. Let's see. So let's see, maybe I should maybe I should stop there for a second. So anybody, because these are a couple of things that people have a lot of interest in. Geothermal, not so much, but ductless and ducted mini splits. So anybody have any questions about ducted and ductless mini splits?
Sure.
Yes, sir.
Yeah, John, my experience, both the ductless and the ducted, obviously they each have the heat pump outside connected to the fan coil inside.
Right.
But my sense is they operate very differently in terms of the fan speed or the volume that's cycling through in terms of airflow.
Well, it depends. So the answer is that it depends.
Okay.
Okay, so one of the problems that we have with mini splits is that the units, so the outdoor unit is variable speed, the compressor and the fan on the outside, and the fan on the inside is also variable speed.
Mhm.
So you got three things that you can vary all over the place, right? And how you do that is important to its efficiency and to comfort. Okay, and so unfortunately, in my opinion, not unfortunately in the opinion of some folks, but unfortunately, in my opinion, is that so there's some engineers over in Japan or South Korea that have said, this is how this thing ought to work. And so they make it work that way. Okay. Whereas in California, like we said, we don't need a lot of dehumidification.
Mhm.
Okay. We have, a situation, the way that people control their units, what people want, et cetera, is different from what it is in South Korea. Okay. And so being able to control these and tell them to do what you really want them to do is a challenge. But you can get either, we have been able to get either one of these to do what we want it to do with enough research and pounding on people as to how to get the settings to work.
Yeah.
But it's not straightforward. Straight out of the box, these run continuously. The fan on the inside runs continuously.
Oh, even in the ductless?
No, yeah, in the ductless.
Like a hotel room.
Yeah, runs
I-
continuously.
I've sensed a ductless cycle on and off.
Yeah.
More than the ducted mini slips. Because I've noticed that they seem to run just very softly all the time.
This guy.
Yeah. and
Okay, so this one's set up better.
Yeah.
Okay, this one's probably set up to run all the time. The fans run all the time because it doesn't know that it uses a temperature sensor in here
Mhm.
to see what the temperature is in the room. Okay, which is a patently dumb idea, especially since you have to run a fan in order to get the temperature up there so you can measure. Okay. So the continuous fan operation on these is a problem, but you can make it not do that anymore. Okay. Let's see. All right. Keys to efficient mini splits. External thermostat. So don't set it up without an external thermostat. You want it controlled by the external thermostat. Okay. You want to have high airflow. These are going into California. Okay. You're not on the rainforest in the Pacific Northwest. Okay. You want it to automatic airflow rather than continuous airflow because they often come right out of the box with continuous airflow. Contractor just puts it in and boom, that's what it does, and that's it. Then this is what I was saying about control options. It's kind of a pain, but I'm willing to work with people to, go back to the manufacturers, beat them up, talk to the engineers, et cetera, figure out how to actually get it to work the way it should in California. Okay, don't compare single speed SERs to multi-split ratings. Mini split, multi-split ratings are way overly optimistic by comparison with a single air conditioner's rating. Okay, and don't think transfer fans will achieve uniform comfort with a ductless system. It just won't. So, okay. Okay. Yes, ma'am.
I'm trying to think of my questions.
Sure. You can think.
Comparing the ductless and the ducted.
Yeah.
The ducted, can you control each room, like separately?
No.
So, like, no?
No.
So if in my house, I say nobody's living in that room right now, I'm gonna turn it off.
Right.
And so it's all or nothing?
Well, it's all rooms or none.
All rooms or none?
Yeah, it's all the rooms that are hooked up to it.
So if I did the ductless, then I.
If you
could-
got one room that you're worried about, you can do a ductless and it'll work.
Right.
Okay. If you got two rooms and they're near each other, I mean, it's not gonna work as well to put two ductless heads in, but you could. If, for example, you have a room, okay, we never use that room except 3 times a year. And you use this room all, most of the time. Okay, maybe you want to put in, maybe you want to put in 2. Okay. But generally speaking, it's not worth it because what happens is that when you have an outdoor unit that's going to be able to take care of 2 indoor units, right?
Right.
So let's call each of them a half a ton. Okay. Okay. So the outdoor unit is it basically, let's call it a 1 ton. Making up these numbers. Okay. So when the half ton, when only one of them is running and it's running on low speed, the outdoor unit, even when it slows down, as far as it can go, it's still putting out too much. And so it ends up actually shoving it into the other room anyway, the one that you said, oh, I don't need the condition. Okay. So it ends up doing it anyway, what you tried to get away from. So, in my opinion, it's not worth it. One good ducted system, in my opinion, almost always, maybe not always, often is probably the best.
So to follow up on that just a bit, if you on a ducted mini split were able to put some kind of valve, if you will, exterior to the split itself, a register, I think we call it, in the ceiling.
Yeah.
And you could open and close the register,
Mhm.
would that affect control over these various rooms?
Certainly. I mean, it would mean that more of the conditioning goes to the room that you haven't closed off the register to. It also means that the airflow through the unit will go down, which means that it's going to do more dehumidification that it doesn't need to do, which means that it's going to be less efficient than it would have been. So yes, you could do that. I would suggest not doing it,
Everybody's gonna laugh at me.
but you could do it,
But like contractor wants something different.
Yeah, I had an organizing trainer. His name was Fred Ross. He was the person who discovered Cesar Chavez in South San Jose, and brought him into doing organizing and trained him to do organizing. Anyway, Fred would have this thing when somebody would say, "Okay, Fred would say, okay, what are you guys going to do about this?" And somebody would say, "Oh, we're going to do this and this and this." And he'd say, "You could do that. It won't work, but you can do it." Yeah.
Yeah, I think if you want to have multiple zones in your house, because like, okay, I'm not going to use that section of the house. Then what you do is you put in separate ducted units or ductless units. And John recommends that they run off a separate heat pump, each of them on the outside.
But then you've got a huge expense and a lot of heat pumps sitting around the perimeter of the house.
Oh, yeah.
So it
Well, you
it
know
would be
what,
less,
you-
it would be less
Yeah.
expensive to just cool or heat the room that you're not using.
Then divide the whole.
Because
thing.
it's kind of
Just
like
in
when
my
we used to
house.
put out outdoor heaters for events. And we would tease, we're like, well, we're trying to heat infinity.
Yeah.
It's never gonna get there. Because air moves like water.
Yeah.
It's really hard to make it be contained.
Okay, so air conditioner heat pump selection. So it's kind of a review. Cooling ratings, you want to look at EER, not SER. Okay, heating ratings, you want to look at COP, not HSPR. Okay. Look at the possibility of having short duct runs and the possibility of having a duct runs inside conditioned space as opposed to through an attic, through a crawl space. And so here is a house. This is one of our Stockton houses. And originally, let's see, there's a chaseway here where the ductwork used to come up. And then it went, there were two runs that went over there. There was one run that went over here. There was a run that went over there and a run that went over there. Okay. And it through the attic. And it, terribly inefficient. Okay. And we actually kept the central unit. This is not a ducted mini split, although ducted mini split worked really well here. And in later iterations, we did ducted mini split here. But so we just took the existing unit and we put it into a box here and we went short duct kitchen, short duct living room, another short duct living room, short duct master bedroom, voila. Okay. Beautiful, works beautiful. It's very comfortable and it used a lot less energy with exactly the same unit in the house. Okay.
Where did you put the external thermostat on this?
In this particular case, I wonder where it is. Honestly, I don't know.
Where would you put it?
Where would I put it? I don't know. I might put it over here.
In the largest unit?
Well, a lot of thermostats are on the remote now.
So,
Yeah, it's wherever you're standing with the remote.
Yeah,
control.
well, that's why you have to tweak it to where you are.
yeah. So that's my recollection, but boy, that was a long time ago. Yeah. Okay. So don't oversize. This is one of the hardest things to make happen because you're going to get a massive amount of resistance from the contractor. But when you put in an oversized unit, whether it's a conventional unit, a 2-speed unit, a mini split, when it's oversized, what it does is it's going to first of all start up. So it's a variable speed unit. It's going to start up on high speed. Going to say, oh my God, I have to hurry. These guys really want heat. They want it really cooling. So it starts up on high speed. And after a little while, it says, holy shit, I'm cooling this place off way too fast. I better slow down. So it'll slow down. It says, oh, it's still too fast to shut off. So it'll shut off. A little bit later, they forget what they learned before, and they do the same thing, boom. Okay. Yeah. Okay. Whereas what you want when you have a variable speed machine, the ideal, the theory, okay, which you can get close to. We haven't actually had any machines, by the way, that really did this, just to be clear, okay, is it goes, and let me try this. Oh, a little bit more, a little bit less. Okay, this is cool. Oh, that's a little bit too much. Oh, okay, a little bit more. And it just keeps going, okay? That is how a variable speed machine should work. I mean, that would give you the highest efficiency if you could get it to do that. And so that's what you're trying to get it to do. So when you oversize, you make it less likely that you're going to get something that approximates that. I mean, when you look at a sales pitch on variable speed unit, that's what they'll show you. They'll show you, oh yeah, look at this really nice. Not how it works, but it's a good sales pitch. So, let's see. What else? Okay, pay attention to the initial installation. So make sure that it ends up with it. Let's say you want 500 CFM per ton. Does it really have 500 CFM per ton? Or does it really only have 350 like contractor always says? Okay. One of the biggest restrictions on is that people have these furnaces, air conditioners, heat pumps that were designed, and I put that in quotes, okay, to use a 1-inch rock catcher filter. just like fiberglass filter, air goes through it, cat hairs and dog hairs might get caught, and then after a while, then it catches some dust, et cetera, et cetera, et cetera. Okay, 1 inch thick. Okay. And they say, oh, no, we really want more filtration. We want to, we're worried about asthma. We're worried about particulates. What we want is a filter that really, really filters those out. So they go out and get a 1 inch thick MERV 13 filter. So, and it's called a high efficiency filter. Well, it's actually really good at filtering those particulates out, but it's really bad at letting air go through. And so when the air doesn't go through, you don't get your 500 to 600 CFM per ton. And so that's why when you do the original design and get it put in, when you put in a 4 inch pleated filter, you get a filter. You can get a 4 inch pleated filter, MERV 13 filter, that has so much area because it goes back and forth 4 inches across instead of 1 inch across, that you actually can get good airflow through it. And then, typical in the field, a contractor comes by, says, oh, I got to do your annual checkup. Oh, you're low on refrigerant. I'll add some. Well, wait a minute. Why do you have to add some? It's a closed system. Oh, I don't know. The person before, must have done it wrong. You were the person before. Oh, well, maybe there's a leak. I better put some in. Okay. If you really need refrigerant, okay, don't put it in until the leak is fixed. R410A, which is a current predominant refrigerant, okay, is a massive greenhouse gas problem, okay? Way bigger than carbon dioxide, way bigger, at least 2,000 times bigger than carbon dioxide. I'm not sure I got my number right. It might even be 4,000, but anyway, who knows? It's multiple orders of magnitude bigger than carbon dioxide. So you don't want it leaking out. Very bad idea to have it leak out. Okay, any multi-stage machine, so a variable speed machine, a 2-speed machine, a heat pump with an electric resistance backup, any of those machines, you want to run them at a constant temperature, okay? Because you don't want them kicking in to their higher speed, whatever it is, whether it's electric resistance or whether it's higher speed on the variable speed machine or high speed on a 2-speed machine. You want it running as much as possible on the low speed, okay? Which means keep it nice, one nice temperature, okay?
And one runs a machine at a speed by turning up or down the thermostat?
Well, so for example, let's just talk a conventional heat pump for a second with electric resistance backup. So if let's say, when we found this early on, back way before 2-speed machines were even in use, okay, up in the foothills of the Sierras, is that we had this thing we call dueling managers, where one of the adults in the house would turn the thermostat down because they wanted to save energy. And the other person would come along and turn it up because they were cold, okay? And so what would happen is that when the person turned it up, it would go into electric resistance backup, okay? Massively cost a lot of electric power, which then the first person felt totally justified in insisting on turning it down again, et cetera, et cetera. So, yeah.
Is there an optimal speed or optimal temperature to set it at that?
Whatever you can be comfortable at with, I mean,
In democracy, we all vote, right?
well,
We've been
when
to
there's
the house?
2 people in the house, you've always got to figure out what that is. It's like, I mean,
You find the middle ground?
we're kind of blessed. I mean, I know Sylvia and Trout have done something different. But what happens with Sheila and I, which is, Sheila sets it at 70, and sometimes that's plenty warm. And then when it gets kind of cold outside and stuff like that, I'm feeling cold, and I turned up to 71, you know, and then she turns it back down. The good news for us is that number one, we don't have an air conditioner. Okay. And number two, we don't have a heat pump. So we have a single speed furnace that responds properly to that kind of foolishness. So, yeah. So.
So what do we do differently?
What do you do differently?
Yeah. What do
Well,
we do?
Trout goes and turns it on or off, and you go do the same on different times, if I'm not mistaken.
I might turn it down actually. Sometimes when it's at 69. Well, it really depends on the weather.
Yeah.
Sometimes the 69 can be hot.
Right.
And then other times the 69 is cold.
Agreed.
We turn it up.
Yeah.
You know, by a
Yeah.
notch or something.
But then Trout doesn't use the temperature version. He uses the off-on version, right? That's what he says.
I think so. I don't know if he has done the other adjustments. He is not.
Yeah, no. He does the off. When what he has said
He does the off.
is that he uses the off-on switch.
I go up and down.
All,
Right.
all off or all on?
Yeah.
Yes.
Right.
All on up.
Well, and I don't remember if that's it. That actually might be a dual fire furnace. I'm trying to remember. But they have a furnace, not a heat pump, and so they get by with it. Okay, let's see. I think that's about it. Oh, people sometimes want an estimate of the costs of running these things, and so I'm comparing it with a delivered therm of heating. Okay, so a standard heat pump will cost about $3 a therm, 2-speed, $227, a short duct mini split, $1.82, the standard gas furnace, $235, 95% gas furnace, $211, and a boiler, which we hardly see any around here, $1.69. So that, just to give you an idea of, okay, what's it gonna cost me on an annual basis, just relatively speaking. I can't tell you how much it's gonna cost for your house, but that's a comparison I can make.
Although the heat pumps both heat and cool, does the boiler heat and cool?
No, it only heats.
Well, it could cool in the winter and it could heat in the summer.
Yeah, a boiler's really good at cooling in the winter. You turn it off and it gets cooler.
On the beach house and they'll get cooled off. Well, then that entire slab cools off. So then you'll pump cold for the next 2 days. So we have a big sign that says, please don't turn it below 58 even in July. Because once the water in those pipes gets cold, it's sitting on the, like we know what the temperature of our ocean is. So that sand is at that temperature. So it takes a really long time for the boiler to heat the slab back up.
Yeah, so you're using a boiler to heat a slab. So, and what I'm actually speaking of here is using a boiler to heat convectors, which are the little things running along the wall with hot water running through them.
I had one of those too.
Yeah.
Alex still has one of those in her San Anselmo home.
No, they're actually a really good system when they work.
Sometimes
When a slab one leaks, that's a bit of a problem. But
Or when your wife can't stand hot feet.
oh, really?
Yeah.
Oh, because I've always felt they were so comfortable.
Gradient slabs.
Yeah.
I love
It's like walking on hot coals.
But then you get some shower shoes.
No, not even that.
No. Okay, I think that was definitely the last one. Yeah. Any other questions? Anything online?
Nothing online, but wow, a lot of great information. So
Thank
interesting.
you.
Thank you so much.
You're welcome.
Yeah.
And then, do you have a boiler, yes? Or did yours get converted?
Yes, furnace. And we added air conditioning last year. Climate change is causing it to be hotter and hotter
It
in
is.
Terra Linda.
Isn't that amazing?
Terra Linda 20 years ago, we had 2 or 3 really hot days.
Right.
And now we got 3 or 4 of them in a row and the house heats up and doesn't cool off.
Right.
It's more
Mm.
Quarter Madeira and it's getting colder and colder.
Yeah, so
Everything heats up,
and
we
I
get
would
cold.
encourage you to take a look at a whole house fan. Because when it gets cool at night, when you vent all the air through, when you said the house doesn't cool off, okay, which is true because it's got some insulation, it's got some mass. If you move out cold night, outdoor air through the house, then it will cool off the house and it will reduce the amount of air conditioning that you need to do. Or it'll make it more comfortable on the days you don't use air conditioning anyway.
Especially if you have a multi-level house. At 4 o'clock, usually the heat breaks and we get some breezes. So if you could essentially figure out a circulation effect, that'll dump a lot of heat outside the house.
And the reason why I say ducted outside is because a conventional whole house fan dumps into the attic. And what happens there is that in order to let the air out of the attic, you have to increase the venting in the attic. Okay, which in itself isn't a problem in the summer, but in the winter, it means you end up with a colder attic, which means your heating bill goes up because of the whole house fan, not because the whole house fan is leaking or because it's on or anything like that, because you put so much venting in the attic. So you're much better off by venting it straight outside.
Yeah, I would really recommend that if you're dealing with a house that too hot, too cold, because the temperature is John's focus of first address insulation.
Yeah.
Whether that's windows, double pane windows, sealing them.
Yeah.
Figure out how to re-insulate your walls and crawl space and ceiling space.
The
That-
only thing to
That
be
will
careful
get, that
of-
will make your house permanently comfortable.
Mhm.
Then you can go to the mechanical element of, how do you change the air?
Interesting, RGC has a fascination with air sealing houses
Uh-huh.
and loves it.
Yeah.
And he says, and people are like, oh, but they're single pane windows. He's like, you live here. The windows don't matter. It's your electrical outlets that are letting all the hot and cold inside of your, because nobody puts the seal just around the outlets that are in the wall. So everything's going in and out through the walls around your outlets and out through the attic.
Right.
Elliot one time made the mistake of sealing up a house so well, and then they were doing the blown in insulation.
Uh-huh.
And he didn't leave any venting. And he had sealed it so well that all of a sudden they heard boom. And all the drywall blew off the wall into the living room. All the insulation went everywhere.
Yeah.
So then they had to go and drill relief holes and then go back and air seal them afterwards.
Yeah.
Because he had made it that the air couldn't get out any other way. So it blew the wall off.
Yeah.
And it's Elliot. So he had screwed the exterior wall on. So it
Yeah.
came through the drywall.
Yeah. Yeah, my worst insulation story was we blew the insulation in an attic. This was low income weatherization. We blew insulation in an attic, and the parents, the older folks, lived upstairs, and that was all cool. And their son, was blind, and he came home. He got a ride home. He didn't drive home, but anyway. and his place was in the basement, so he went down to the basement, and he ran into a mountain of cellulose insulation, which had made it all the way down into the basement. So,
Oops.
yeah.
Surprise.
Fun.
Yeah, I also experienced it just in a new house, and the sizing John mentioned in terms of just they drive by the house and they look at it and they say, how many square foot? 4,000 square foot. 5.5, 6 ton. And you go, no, we got extra insulation, thicker walls, special windows and all this stuff. And then you bring in the energy consultants to do all the calculations. And when they get done, even though that you give them all of the R rating of everything, windows, ceilings, doors, floors, you know what I mean? they throw in a multiple factor.
Yeah.
There's no justification for it,
Right.
but it gets them back to the 6 tons.
Right.
And it's just effing waste.
Wow. Thank you so
Very
much.
nice.
Yes.
You're welcome.
Thank
Thank you. You're welcome.
Very.
A good topic for Earth Day of how can we be a little bit more efficient.
Yeah.
Thank you for
Yeah,
tying
sure.
tying well into our theme. And always fun to learn new things.
So one of the
Eat
things that
snacks.
I brought up at rowing, which I'll bring up right now, is that when COVID came along, folks heard this word ventilation that they'd heard before, but they really didn't have any idea what it was. And so they think that, oh, if I run my furnace fan or my heat pump fan continuously, I get ventilation. No, that's called circulation.
That's sharing the germs
Okay.
to all the rooms.
Ventilation, okay, is taking outside air and putting it in the house and inside air and putting it outside. Okay, and unless it does that, it's not ventilation. Okay, and so ventilation for COVID, in my opinion, and quite a few people now, ventilation is probably the most important thing we could do. And if you can't do enough ventilation, then you can do filtration. Okay, but filtration is really second, is a lower level of desirability from ventilation. So if you know, filtration is a good idea, but ventilation is a way better idea.
We talked about this until there's smoke outside.
Right. And then filtration is your only answer.
Is your best.
Yeah. No, so Mission Neighborhood Health Center, I at first during COVID, I increased the ventilation. But then the fires came, and so we had to switch to filtration instead of ventilation. So
I have one more question for you. When you were talking about the fan in her house, and you said don't vent it outside, don't vent it in the attic.
right.
How do you vent it outside?
Well-
Where does it, I mean, looking at my walls, it,
Well, okay, so generally a whole house fan, the fan goes in the ceiling, blows air into the air.
right,
Okay, we take a duct from that, although it's not designed for it, and put it out to the gable end, or
oh, okay.
you know, and it goes outside.
I've seen it go to the ends or to the roof.
Right.
Oh,
You just want the air to get all the way out.
Ejected it. Okay.
Yeah.
Yeah, instead of dumping it in the attic.
Right.
Give it a hose to dump it all the way out.
Okay, that makes sense.
Right.
I was envisioning things down my walls.
No. Yeah. No. Yeah, and I mean, if you think about it, it's actually what you may have experienced in your parents' house, and that was a window fan. That maybe if they did it really well, they pulled air out in one room and let air in from outside in the other room where your bedroom was. So I mean, that's the best way to do it. You can also blow it into your bedroom, and obviously any air that comes in, there's a kind of rule it has to leave somewhere. You know, but
Hang the dynamics every time.
Yeah.
It comes in there.
Well, thank you all for coming.
Thank you. Good stuff.
Gil, have you chosen one for your remodel?
I don't know if Cal told you, so we're in the midst of, the tail end of the remodel. And very early in the process, I told my wife, I don't have time for any part of it.
Oh,
So literally, if you ask me just about anything about the project, the answer is, I really don't know.
ask Cal.
She's not here. Contractors were like, yeah, sure, we'll see. Because I've been in real estate my whole career.
Yeah.
As a developer and so forth, but I really, every once in a while, it's, just the other day, they were shooting in some granite for the pool, and I hadn't seen the plans like 10 months ago, the last time I saw it. And I sent the Cal and said, you know, maybe I'm just wrong, but that wall just looks like it's too high. And she said, no, everything's fine. I said, okay. You know? So we had one of these oh shit moments also, the deck that they built, that was too big, and I thought when they built it, I thought, "That looks like it's too, I would love this to be our deck." They had poured footings and everything, and rip it out. So this time she went over to the pool contractor and said, you know, my husband says he thinks that wall's, oh no, it's fine. I see him up there. So there's an old rebar, they had poured the kind of. Taking it all down. So we got about, one thing is that.
I'm like, you have a pretty good gut instinct for these things.
If you come to our, I mean, I'm just concerned already now. I am living in the house. I see what we've done. We had our entire heating system replaced. And there, I mean, there's just, it's a caterpillar that's down there. I'm like, okay.
Well, John was